what's the physical cost of realizing such computations? I just now mentioned energy. And so it is very interesting to consider the fundamental limits upon computation imposed by the laws of physics. And I want to spend a few minutes on that by talking about this second topic, thermodynamics and computation. It's really remarkable in many ways how I've been able to tell you a great deal about computation so far, ignoring the laws of physics. And really, the physics department doesn't like this in many ways, just from a standpoint of fundamental principles. Shouldn't everything be governed by the laws of physics? How come I was able to give you that strong church-Turing thesis, which I erased over here, and it said absolutely nothing about Newton's laws or about Maxwell's equations? Why? It seemed like it was a construct of pure math, really maybe pure audacity to be able to ignore the laws of physics. And there was a whole group of researchers, scientists around the world, who thought deeply about that in the early 1900s and the late 1800s. And they came up with this realization about thermodynamics and computation. And this was, in my own journey in science, one of the starting points about how I got interested in quantum computation. And that's one of the reasons I want to share this little piece of the story with you today. And the idea starts in 1867 with a construct which I think many of you already know about, known as Maxwell's demon. These were the good days when you did science by writing letters to each other, researchers, and postcards. I don't know how many of you have seen the Stern and Gerlach results that were sent to a professor in Americas or in Canada. Otto Stern took a snapshot and printed it on the back of a postcard and mailed it. Okay? I don't think I could do that today. Maxwell's demon likewise showed up first, as far as I know, in correspondence between James Clerk Maxwell and another fellow scientist. How many of you know Maxwell's demon? OK, about half. So let me actually describe this. And those of you who know it, feel free to ask me questions, get me to add in, fill in some more of the detail. So here's the scenario. We have a cylinder with gas molecules in it. Okay, and these gas molecules are careening around at different velocities. And some of them are going to be hot, and some of them are going to be cold. So if I were drawing this carefully, I would draw the links of these arrows representing in some way their velocity. Okay, so longer arrows faster, shorter arrows slower. Now, this box, let's say, has a partition in it with a hole. And this partition has a sliding door. And this sliding door can be actuated by this clever little person sitting inside the cylinder, a very, very small cylinder. I mean, small person or a very large cylinder, let's say. A very demonic person who has his or her hand on this door, and this demonic individual, Maxwell's demon, looks at each one of these molecules and sees this molecule going about to hit this door. And what Maxwell's demon does is try to achieve this configuration where he or she puts all the cold molecules on the left and the hot molecules on the right-hand side by virtue of looking at them and selecting them one at a time as they can go through the door. So by doing this, Maxwell's demon should be able to take like all the gas molecules in this room and put the hot ones on one side and the cold ones on the other side, and then create an imbalance of temperature, by which virtue of which, now Maxwell's demon hasn't done any work, apparently, because all the demon had to do was open and close the door. So it seems like this demon is able to accomplish something very useful, create a configuration of gas which could then be used to extract energy and accomplish work and so forth, and yet expend exceedingly little energy in comparison with what the demon could harvest from the gas molecules in a room, because any random distribution of molecules in a room, like in this room, have a wide distribution, some which are cold, some which are hot. So why shouldn't the demon be able to separate them just like this? Okay. This is a real question, and it's connected to computation in a way that I hope you'll see in a moment. Now, this actually is impossible. And although I put exclamation points here, really there should be a question mark, because at first it wasn't understood why it's impossible. Is it because of the energy required to move the wall? Is it because of the measurement? Maybe it's too hard to measure single molecules. Maybe by measuring them sufficiently well, the Maxwell's demon would end up kicking the molecules in the wrong place. Or is it hard because there's a need for intelligence in some way? Like maybe no automaton could accomplish this, but a graduate student could. So these were really the type of topics that were discussed in this day and age about Maxwell's demon.